Now we're going to keep going with Pierre, and we're going to do a little bit of a deep dive into libp2p. Give him a round of applause.
Hello? Okay. So, hey everyone, my name is Pierre Krieger. I'm going to talk about libp2p. Does it work? Yes. I'm going to talk about libp2p. So first of all, what is libp2p? It's the networking stack that we're using in Substrate and that we're going to use in Polkadot as well. It's not designed by us, it's designed by Protocol Labs, and they're also writing the specifications. It was originally the networking stack of IPFS, but they extracted it into its own project, and now it's a very generic layer that we're going to use. Disclaimer before this talk, you don't need to know any of this in order to use Substrate. That's like all low-level details. Everything is handled for you by Substrate. So feel free to not listen, but I invite you to listen anyway. And there's a workshop at 2 p.m., but it's actually full, so ignore that last part. And to start, I'm going to go into the basics of what a peer-to-peer network is. So a peer-to-peer network, the characteristic of it is that there's no central server, with a small exception of bootstrap nodes, which are kind of central, but not exactly. Each member is called a node, and they are all equal and ideally connected to one another, either directly or indirectly. Each node has an identity, which you can see. It's these QM things. It's a bit small. Each node has a private key and a public key. The identity of the node is the hash of its public key. That's how you identify it. That's how you know this node is this person. And in libp2p, this hash always starts with QM. Connections between nodes are also encrypted and multiplexed. So you don't have raw streams of bytes. It's all encrypted. You cannot know what's being communicated between two nodes. And I'm going to go into more details for what multiplexing is. In your Linux machine, your kernel assigns a port for each TCP or UDP connection, but all the traffic goes through a single cable, and that's called multiplexing. The kernel automatically divides the traffic depending on the port for you. In libp2p, we also have that. It's done on top of the encryption layer, so every stream is grouped into one and the result is encrypted. And you can open and close substream individually between two nodes of a connection. So let's see how it works in practice to establish a connection between the two nodes. Imagine that Alice is listening for incoming TCP connections, and Bob knows the IP address of Alice. Bob dials a TCP connection to Alice. Small note here, libp2p only uses TCP and not UDP, contrary to lots of other peer-to-peer systems. Then we do a TLS-like handshake. We exchange keys. We perform a Diffie-Hellman. Afterwards, everything is encrypted. And on top of that, we apply multiplexing. And as I mentioned, if Bob knew the identity of Alice, it can also make sure that it's really Alice and not someone else. But there's a twist. libp2p is more generic than that. You don't need TCP. You don't need any specific protocol. It's generic over what we call a transport. It can be TCP/IP. It can be QUIC. It can be Tor, Bluetooth, whatever you want. There's a prototype. I mentioned Bluetooth because there's a prototype of Rust libp2p Bluetooth. And when I say a prototype, it is a prototype, not something that you should use. The only restriction on transport is that they must be reliable and ordered, just like TCP is. So that's why you cannot use UDP. But you can use something that works on top of UDP. So libp2p is generic, and you have a concept of multi-address, which is the generalization of an IP address. You don't have TCP, you have transports, and similarly, you don't have IP addresses, you have multi-addresses. So I'm giving a few examples. That's an IP address TCP/v4, IPv6, sorry, and you also can pass DNS names. And similarly, libp2p is generic. You don't have a single encryption protocol. You don't have a single multiplexing protocol. Instead, every time we establish a connection, we negotiate which protocol we want to use. which has the huge advantage of this is that if you want to change your encryption layer, well, you can. You just accept both and you switch to the new one. And you can do an upgrade thanks to this. The protocol negotiation protocol is named multistream select. Multistream select is what you use to say, hey, I want this encryption protocol or this multiplexing protocol. So let's revisit the link establishment between two nodes. So similar as before, but with a few tweaks. We assume that Alice is listening for incoming connections, not necessarily TCP. And Bob knows the multi-address that Alice uses, not necessarily an IP address. Using the transport, Bob opens a connection, again, not necessarily TCP. And once the connection is established, we use multistream select to say to decide which encryption protocol we want to use. And then again, on top of the encryption protocol, we use multistream select again to decide which multiplexing protocol. So which protocols does Substrate use and support? The answer is TCP and WebSockets right now. Why WebSockets? Because we want code from within the browser to be able to connect to our nodes. That's not working right now, but it's going to be at some point. For the encryption, we use a protocol named Sekayo, designed by Protocol Labs, which we are going to replace at some point because it's roll your own crypto, and we don't want to do that, obviously, because you never roll your own crypto, rule number 1. For multiplexing, we use Yamux and Mplex. Yamux is done by HashiCorp, and Mplex is done by Protocol Labs. And Mplex was designed to be very simple to implement, that's why it exists. And it's the only protocol supported by JS-libp2p. That's why we need support for it in Substrate. Substrate supports WebSockets. On the top right-hand corner, you can see the logo of WebSockets. I didn't know that WebSockets had a logo before writing this talk, but now I do, and you do as well. So to go into more details about WebSockets, by default, Substrate only listens on incoming TCP connections, which means as soon as the connection is established, it's assuming that you have libp2p traffic happening on the link. But if you pass this CLI option listen address with a /ws at the end, it's going to assume that the incoming traffic is an HTTP request followed by a WebSocket upgrade. And then the actual libp2p traffic is done within WebSockets. And again, the advantage of this is that code within the browser can actually talk to us. So right now, Substrate supports TCP, WebSockets, Sekayo, Yamux, Mplex. But in the future, what we want to support is for the main protocol, QUIC, which covers at the same time transport, encryption, and multiplexing. QUIC, for those who don't know, is designed by Google and is going to become an IETF standard pretty soon. The advantage of QUIC is that it uses TLS 1.3, meaning you cannot differentiate QUIC traffic from HTTPS traffic. So people don't know if we're talking Substrate, Polkadot, whatever, or HTTPS, except for the fact that we are connecting to port 13,333 and not 80 or 443, sorry, which is kind of suspicious. But other than that, from the traffic, you cannot tell whether it's HTTPS or Substrate. Maybe a hypothesis is nQUIC, QUIC plus noise, because QUIC is generic over the encryption layer, actually. So we don't necessarily need to use TLS 1.3. We're going to see if we can use noise. But in addition to QUIC, we still need, as I said, support for WebSockets for the browser code. And on top of WebSockets, we would use the noise encryption protocol and Yamux. I just put this slide as a joke, maybe Bluetooth. I don't know, that's a prototype. Bluetooth is not an official Parity project. That's me having fun in my weekend. I'm now going to explain what happens once a link is established. So as I said, there's multiplexing negotiated on top of a connection. And once you open a substream, you negotiate which protocol to use in this substream, in particular using the multistream select protocol, which is the same as we used before for encryption, and to negotiate the multiplexing. Example, if you want to request a block from another node, you open a substream, you say, hey, I want to use this protocol name sub for substrate, dot for Polkadot, or whatever you want. You send the request, you wait for the answer, you close the substream. To announce a transaction, you open a substream, you negotiate which protocol you use, the same one. You say, hey, this is my transaction, and then you close the substream. To send a ping, to verify that the connection is still live, you open a substream, you send the ping, 32 bytes of random data, you wait for the answer, and then you close the substream. What I'm trying to explain is that substreams are very short-lived. It's not something you keep open for minutes or hours. It's you open a substream, you do one specific thing, you close the substream. So which protocols do we use? More into details. For Substrate, for everything blockchain related, we have a homemade protocol. So in LibP2P, you are free to design your own protocol, and that's what we did with this one. I didn't mention its name, but it's what you use in the protocol ID of your chain specs. So when you write your chain specs, you have a field protocol ID, and you write a 3-letters word, and that's the name of a protocol that we negotiate with other people. And that's used for everything blockchain related, which means gossiping and sync. For the rest, we're using standard LibP2P protocols, ping to check if a connection is still alive, ID to gather information, and Kademlia for discovery. And I'm going to go into some details. Ping is used to check whether a connection is still alive. Otherwise, a connection might be lost and we don't know about it, so we just ping regularly. So how do we do that? As I explained, you open a substream, you negotiate the /IPFS/ping 1.0.0 protocol, you send 32 bytes of random data, you wait for the remote to send back the same data, that confirms the remote is still alive, and then you close the substream. Gather information from a remote, that's regularly done every few minutes. I don't remember the exact delay, but every few minutes we open a substream, we negotiate the /IPFS/ID/1.0.0 protocol. We wait for the remote to send back some information about it, and then we close the substream. Which information exactly? That's some protobuf code which you cannot see. That's why I rewrote it in white. You have a general version of protocol. So for IPFS, this would be IPFS, but for Substrate, it's Substrate something something. The agent version, which is the equivalent of user agent in HTTP, it indicates the version of your client. So for IPFS, it would be Go IPFS. I wrote some IPFS example because LibP2P is the networking stack of IPFS, but obviously for Substrate, it's different strings. The public key is the public key of the node, but we don't need that. I included it to be exhaustive. Listen address is the list of addresses that the remote is listening on. Observe addresses is the address the remote sees for us. And protocols is the list of protocols that the remote supports. The important field here is observed address, because that's how we know what our external IP address is. So to explain again, every few minutes, we ask the remote to send back information which includes our external IP address, and that's how we know it. It's similar to the stun protocol, but directly backed into LibP2P, if you know what stun is. And finally, the last protocol we use is Kademlia. So I'm not going to go into details about Kademlia because that would take me 20 minutes, and I don't have 20 minutes. Basically allows us to discover which nodes are part of a network, their identities and addresses, so that we can connect to the network. Otherwise, we cannot connect. That's what Kademlia is for. I don't have my slides on this screen. That's why I have to look here. It's extremely annoying. And it's more off topic. We're using MDNS. So MDNS consists in broadcasting every few minutes a packet on the local network, a UDP packet containing our identity and our addresses. And thanks to that, you can actually discover the nodes that are on the same network as you. You can try it. You can start a Substrate node and another Substrate node on the same machine or on two different machines on the same network, and then we automatically connect to each other, which is quite cool. I don't know if you agree with that, but I find that quite cool. You can disable that if you don't want it with the -- no MDNS CLI option. As for the substrate-specific protocol, as I mentioned, it's a homemade protocol. Its name is based on the protocol ID. And that's very important because if you are writing a blockchain using Substrate, it's not going to be able to talk to other blockchains using Substrate. Otherwise, there would be a lot of confusions. And that's how we differentiate them. If you accidentally connect to another chain, it's not going to be able to communicate. Big mention, big note, this protocol is very work in progress. There's no specification. We are not quite sure exactly how it's going to look like in the far future. That's why we are not specifying it right now. But we will have to do that as obviously at some point. And that's what we use for gossiping and sync. And for the last part, how it works in Substrate. So I'm going to cover here everything specific to Substrate and not to P2P in general. Substrate uses Kademlia and MDNS for the discovery mechanisms, as I mentioned. We periodically make a random Kademlia iterative query. That's how we discover a network. That's exactly the same thing as what Ethereum 1 does. And Substrate, important point, Substrate always answers all Kademlia requests. Even if you have 1,000 incoming connections, it's going to answer them all. I'm going to go to explain why I did that afterwards. Polkadot and Substrate are under attack by IPFS nodes at the moment. I don't know if you know that, but we accidentally connect to IPFS nodes at the moment. And that's actually a problem we have that we need to solve. Why is that? Because IPFS and Substrate use the same networking protocol, and so at some point, some person probably tried to write the address of an IPFS node into Polkadot, and he connected, and since then they exchange information, and the two networks are interconnected. In order to solve that, we actually have to change our discovery mechanism, because right now we have no way to differentiate between IPFS nodes and non-IPFS nodes. Because Kademlia has no way to know that, and we have to change the discovery mechanism. As for the actual blockchain stuff, we try to maintain 25 open connections that we opened and 25 connections that have been opened by other people. Again, that's exactly how Ethereum 1 works, at least the Parity Ethereum client. I actually don't know how Geth does, but the Parity Ethereum client does exactly the same. So we're trying to maintain between 25 and 50 connections at any given point in time. And if a node connects to us, if there's no slot available, we tell it, hey, I'm full, you cannot talk blockchain to us. But that doesn't mean we disconnect from this node. You can still connect for Kademlia request, for identifying, for ping. You're just not going to be able to go gossiping and sync through us if we are full. That's like these two purposes for opening connections, which are Kademlia and gossiping and sync. And they are kind of interconnected because we use the same connection for Kademlia and for gossiping and sync, but they are kind of independent. Even if we are full, we still accept Kademlia requests. And even if we are full for outgoing connections, we still perform Kademlia requests by dialing other nodes. We only ever allow one active connection between two given nodes. And that's why we have multiplexing, so that we can do multiple things on the same connection. When it comes to code, the general architecture of Substrate is these three crates: network, P2P, network, and peer set. Network P2P is everything very low level, very close to the wire, contains the discovery network, the discovery mechanism, and how we actually connect to nodes. It manages the 25 active outgoing connection and 25 ingoing. The network crate contains the sync and gossiping code. It's on top of network P2P. And the peer set is something that we extracted from network P2P. It used to be network P2P. And it's what decides which nodes we have to be connected to at any given point in time for blockchain, for gossiping and sync. That's what Rob mentioned earlier. We are trying to maintain a reputation for nodes. I'm going to go into more details. And we extracted peer sets so that we can share it among the code base. If you're writing your own consensus layer, you can get an arc to a peer set. And as I said, it's done for this reputation system. The peer set has a value of reputation for any given node that it knows of. And this reputation, just to be clear, is not a global reputation. It's only from a point of view of any given node. If a peer is not useful to us, we decrease its reputation. That's done by the consensus code. If the consensus says that a node is bad, it's going to decrease its reputation. And the peer set is trying to maintain connections with the nodes with the highest reputation, but with some tolerance, because otherwise the network would never move. We want to allow newcomers to be able to join our nodes, and that's why we want to randomly disconnect existing connections to replace them with new ones. And to finish, here is the roadmap. So what we want to do in the future for networkly P2P, networkly P2P should be configurable with the discovery and gossiping mechanisms. We don't want to necessarily tie to Kademlia and MDNS. We want to allow other discovery mechanisms. If you want to write them, there are other protocols such as Brahms, which are very cool. And we want to make networkly P2P generic over that. Similarly, we want networkly P2P to be generic over which protocol you use for sync and gossiping. We want to write an Ethereum 2.0 client using Substrate, and so we have to do that. We want to plug the Ethereum 2 networking into Substrate. Networkly P2P should also allow non-blockchain strictly related protocols. You should be able to do on-chain messages, send on-chain pub/sub messages to other nodes. And the last point is actually specify the substrate protocol that we're using instead of leaving it as an implementation detail, which is obviously bad. We also want to rework the network specialization trait. Depending how far you went into the code, you might have seen it or not. Right now, it's this very weird work in progress thing that's not really usable in practice. We want to make it actually usable, which will make it possible to have like your own network on top of the P2P network in your blockchain network. We want to add support for quick and noise, and we want to rewrite the discovery mechanism in order to fix these IPFS nodes attacking us. And that's it. I was very quick. Do you have questions?
Hi. Are you planning to introduce some sharing mechanism for reputation peer set storage?
So we need to do that for Polkadot because we want to share the network between all the parachains. Well, not necessarily. We want the collators to be part of a single network, whatever chain they are on, whatever parachain they are on. So we eventually need to divide. The plan right now is to divide the DHT into several slices, and each slice corresponds to a parachain. That's just one idea. I haven't actually looked into details what Ethereum 2 is going to do. I know there's a proposition. I haven't read it yet. But yeah, we need to do that.
Thanks. Quick question. Have you considered WebRTC as a transport?
So considered, yes, but very briefly. We will need to write a WebRTC implementation in Rust because there's none at the moment, and that's not a trivial task. I'm also not sure. I've heard from Protocol Labs that WebRTC is also kind of buggy once you have more than 7, 8 connections active, so it's not ideal.
Any other questions? All right, then thank you very much, Pierre.